I find that software testing is quite a bit of a conversation. So when I was trying to think of what I would say to developers about software testing, I started writing slides and I rewrote them so often that I started writing an outline in the text editor and I went, hang on, why don't I just use the text editor? All I'm doing is putting words on the screen. So I'm just using the best tool that I had to hand. So tonight I'm going to be talking about how we build testable software. So we're going to start off with, well, who I am. I'm Morris. You can find me on Twitter at MossandZ. My Twitter handle says it best, I break things so they work. And I work for a startup in the payments industry called Pushpay. So I break financial software so that nobody else does it. And let's get into the assumptions that I have about software. So I assume that software is built in teams. You can build something as a one-person shop, but inevitably you end up shipping it to somebody and they start giving you complaints about your software and they kind of become part of your team. So if you don't want your team to be everybody, have a team. And software is complicated. Software is quite complex. So when we're developing something, we're writing something that is then interpreted by a machine and is also interpreted by other people. So if your code is open source or if you deal with somebody else, they come along, look at your software, go, oh, okay, I kind of know what's happening there, and start writing a little bit of software on it as well. So you're not only having a conversation with a machine, you're having a conversation with other people. That's quite complex. And software involves changing state. Even when we have stateless protocols like HTTP, we end up having wonderful hacks like cookies and headers and things so that we can have state in those, because without state we're not actually doing anything for the moment. Okay, so let's move on to talking about teams. So when we have a team in software, I often like to break it down into different roles that we have. So we have sort of 4 distinct roles that I kind of see, and you can break it down differently, but this is my opinion, so this is what we got. So you have product people. Now product people tend to be involved in sort of answering the question of what should be built. So they're the business people, the business analysts, the product owners, and their job is to work out kind of what you're supposed to be building. It can, for these sort of one-person projects, be yourself going, hey, I should really write a thing in Ruby that produces something in Scala, that produces something in C#, that then produces the same thing back in Ruby, and there's a bit of an Ouroboros. So whatever software you're designing, somebody somewhere has set up what it's supposed to do. And then there's designers, which generally go of what it should look like. So that can mean UI design, that can mean the sort of architecture roles that go, what sort of, how should we get this going? And then you got your developers, and developers are primarily concerned with how should I build it? So your developers and programmers need to work out how they actually take ideas of what they should be developing and designing and implement them, which involves a lot of technical know-how and a lot of choosing tools and languages and experimenting and writing things. And then finally you've got your testers, and testers here, we have a very different question than everyone else. We go, does what has been built to do what it should do? Which is a terrible mess of tenses, and I really could have written that better. But the point I'm trying to illustrate here is that a lot of roles in software development have a forward-facing kind of question. They're like, what are we going to do? How are we going to do it? What should it look like? And the testers often at the end have a backwards-facing question, which is like, well, we have something. Does it do what it was supposed to do? We're looking at something that's been done in the past and making sure that it does what we want it to do in the future, whereas everybody else is just looking towards the future and trying to make sure things work. But today, so it's not so complicated and I'm not continually getting confused with my tenses and things, we're going to focus mainly on developers and testers in this talk. Because you can sort of, I'm not going to discount the product and design roles. They're definitely very important, and they definitely have complex relationships with developers and testers. But if we can focus down further in the development stack to where people are writing the software and people are making sure that it's been written properly, we can have a much more sort of focused conversation. So let's start with developers, developers, developers. So like I said, developers are concerned with how software is built. And you naturally think a lot about how software is implemented if you're a developer. So there was a conversation I was overhearing in the break, which I caught about every second word of it, and people were basically talking about how a certain project had implemented a system that displayed something on the screen. It was a wonderfully complex situation and conversation that basically boiled down to, well, they printed it. So you often are trying to find really neat technical ways to do something, and you think quite a lot about how you can do something neatly and tidily and hopefully maintainable. And I have a wonderful example about this that I'd love to pull out. So there's this project called To-Do MVC in the JavaScript world, and what they do is to help developers choose an MVC framework, which stands for Model View Controller. Now, as a tester, I don't actually understand what Model View Controller means and how you split those three things out, because for me, they're all just one system. They just do the thing where you grab something from the data and you display it on the screen and you allow the person to update it. Like, it's all just one system when you say MVC. But developers dive down in there and go, oh, well, this goes in the model, this goes in the view, and this goes in the controller. And it actually makes a significant difference to them as to how it's implemented, because the code looks very, very different. And these are a whole bunch of different MVC frameworks that I'm going to scroll right past so that I can get down to the vanilla JavaScript one and show you what this actually does. It's a to-do list. What needs to be done? Give an example of how developers want to talk about how things are implemented. Great, cool. And so what can this do? Well, you can click, say something's been done, you can then clear off the completed one, you can reload the page, and it will hopefully have what was on the page again. And this has been implemented multiple ways. And quite frankly, as a tester, I don't exactly care how it's been implemented in multiple ways, because I'm concerned with how the software has been built and how to investigate what it does. It is kind of interesting what framework was used. It is kind of interesting how the developers have done things, but really only so you can know where the seams are and guide you as to where you need to look for how things have gone wrong. So once again, jumping back to To-Do MVC, there's obviously bugs in quite a lot of these frameworks. In fact, if you can see color really well, and if this displays color really well, some of these are in red, which means that they have passed the automated tests of the To-Do MVC. And some of these are in dark red, which means that they don't actually conform to the spec properly for some reason or another. And there's a lot of dark red ones, and then we go back to some red ones. So all these things are kind of doing the same thing, except some of them aren't doing it the same way or aren't doing it right. And I've found before in the past, because I use To-Do MVC as sort of a playground for automated testing and playing around with different tools there, because when I write automated testing, I'm a developer and I actually care how it's implemented. I found differences between frameworks that are supposed to both meet the specification. So that's been sort of quite interesting. But moving right along, I'm speeding through my content. Wow. So testers and developers, we work together on software, and we often work together in contention when we find issues in software. So by issues, I mean bugs. And the thing is, testers and developers come at these from different viewpoints. Like, a tester's entire job is to find these bugs and issues in software. If we don't find any, we either haven't done our job, or our job is way harder because now we have to prove that the system doesn't have any bugs when we didn't find any. So we have to prove somehow that we just didn't miss the issues. And that's really hard to prove because you're trying to sort of prove a negative in that case. So when a tester finds an issue in software, they're often going to be naturally quite elated. Like, I'm a very curious person. I like finding out when things are broken. And sometimes I'm sitting at a desk in an open office area and I kind of go like, woo! And everyone looks and goes, oh crap, please don't pick up your laptop and come to my desk. And then I inevitably end up disconnecting my laptop, walking over to a developer's desk and going, is this what you intended? Yeah, Pete knows. Pete's one of my developers. I say my developers, they're mine, you can't have them. They're very nice, I like them. But sometimes they create issues in software. And we have to sort of think about where those issues come from. Now, developers don't write bugs. They don't write bugs. Nobody sets out to write incorrect code. In fact, if you tried to write incorrect code, and my company recently did this as part of our security training, in one of our exercises it was a lab where it's like, try and write a logic bug. And it's very, very hard to write incorrect code or something that does something wrong. Because as a developer, you know what good code looks like. You know what you can code. You can easily write code that you don't understand. You can easily write code that won't compile. You can easily write code that sort of stretches the limits of what you know and you're not sure if it's going to work or not. But to deliberately write code that looks good but does the wrong thing is very, very difficult. Because I find that bugs happen when developers' intentions are not met. So when you're developing, you hold a mental model in your head of what you're trying to build and how you think the computer is going, the compiler or everything, is going to interpret what you mean. How you have this mental model of, in the software project that I've had, how do I add this feature? So it relies on like the frameworks you have, existing features elsewhere, and how you plug into them. You have to explore and hold this mental model of, how do I write this so it works? And when this model gets slightly wrong, that's where bugs occur. And the mental model mismatch often happens when the developer's expectation of how the code works is different from how it actually works. So if you've ever sat down and debugged some of your own code and gone, well, that's not what I wrote. And most developers will have this experience, and I've had this experience writing test automation code, where you go through your own code and you go, no, that should totally work. I read the documentation of the framework I'm using, and that's what's supposed to happen. And then if you're lucky, you're using an open source framework, and you go into the code of the open source framework, and you dig down, and you go, no, I found the bug. It's not in my code, it's in their code. And then you report an issue, and then 6 months later, they close your ticket. But yeah, so that's what I'm talking about. There's like, systems and software get quite complex because you're often not writing on something that you've written the entire thing yourself. And even if you've written the entire thing yourself, you're writing with past you and future you and present you, and it gets really confusing. But the complexity of a system and software basically exceeds what one person can hold in their head, which is why we have roles like lead architect and things, because you can't be developing and architecting and doing all the things all at the same time. You have to kind of step a little bit and do different things. So that's sort of where these issues kind of creep in, where a system is a little more complicated than what someone can hold in their head at one point. And it can also happen when developers are unfamiliar with work that somewhere else sort of interacts with what they're currently doing. Yeah. So, keyboard shortcuts, right. So how do we mitigate this? Well, the first thing we have to realize is that software bugs are pretty much always going to occur. Like, we're dealing with complicated systems, we're dealing with systems where multiple people work on them, we're dealing with systems where you rely on years and years and years of craft in order to actually get something to boot up and running. So we need to sort of mitigate how we get issues. And how do we do that? Well, that's what software testing kind of is. The idea that we take software which has been written and investigate it and make sure that it works. And ultimately, building testable software is about building it so that that investigation, that work by testers, is easier. And we can actually do this in many ways other than coding. We can do it by working better together. We can do it by thinking about our peoples and processes. And yeah, we can do it by a little bit of coding. We do it by building in sort of hooks in our system for testing. So we can have sort of testing environments. So instead of like, oh, hey, ship it live production and then just make sure it works, we can have a place which is dedicated for making sure that the system works before it's sent out to sort of general public. Or even if you have sent it out to the public, you can have sort of a debug mode on the open source project, something that allows you to investigate much easier, which is sort of my next point, which is tester commands, which I will get quite into. But there's the idea of building things into your software explicitly for the use of testing and not for production usage. And then we'll get into some odds and ends and things I remembered and wrote down in the text file like 30 minutes ago before I got up and started talking. So let's start with working better together. So the first thing is testers and developers have a very different perspective on issues and on technical issues and on coding itself. So I'm very much not a developer. Like I said before, I don't understand the difference between the model of view and the controller. And that's okay because I don't have to in the role that I have in software. But occasionally I will be talking to somebody who will take this to mean that I am not good at my job, which is hilarious because I'm very good at my job. I just not good at development. I'm not a developer. And I've written feigning surprise. Oh yes. So I have an anxiety condition, and recently I wrote in a testing magazine an article about anxiety and imposter syndrome. And one of the things that I wrote in there was about this concept of feigning surprise, which is a form of harassment that is quite common in technical communities. So when somebody doesn't know something, or when somebody is learning about a new system, there will be somebody more experienced at them who will come at them and they will feign surprise. They will go, oh, I can't believe that you don't know the difference between equals and equals equals in JavaScript. That's my sort of canonical example. Nobody knows that difference. But the idea is that you go to somebody who doesn't know something and you treat them as a lesser person and you act surprised in their face and mock surprise that they don't know something. And it is literally harassment, and the only reason people ever do it is to stoke their own egos. And it really needs to be cut out, especially when we're dealing across different roles and teams where people have different experiences, different expertise, and know different things. And that's incredibly important. We need a diversity of perspective in our software, because if everybody only knew the exact same things, something would come out of left field that none of them knew and destroy them. Which brings me sort of to my next point of using common language. So when we're having discussions as a team, we need to make sure that we're actually talking about the same thing. And to do that, we need to make sure that we have words that mean the same thing to everybody in the team. Now that can mean finding a way to explain your system without having to dive deeply into the technical implementation of it. It can mean describing a system in the same language as something else. So at my work, we have a system that allows you to make payments repeatedly. You sort of set up a schedule. And it's alternatively called scheduled payments, recurring payments, or what's the other one? Payment schedules, depending on which layer of the application you are working in. And it can get very confusing when you're talking across teams and across people as to what's going on there. I think our operations team even has a very different word for it again. And it's been really interesting for us to find out that you need to start building up glossaries of what teams actually mean when they use certain words. And actually one of the things that we've done in extreme cases where everybody's sort of getting it very differently is we use a chat system called Slack. And in there you have a thing called Slackbot, which you can say when somebody says this, respond with this. So when somebody said, oh, it's in this system, it responded, no, no, no. It's here. This is the name for it. It was very annoying for quite a while, but it worked wonders and allowed us to actually get along with each other. And another thing that I put in here in working better together is code review. Now, code review is entirely something within the purview of developers. You don't actually need to grab in the tester to look at your code and go, does that look right? Because they're going to look at your code and go, oh, I don't know, have you run it yet? So as developers, what you can do is get together and have somebody else just look over the code that you've written and just a bit of sanity checking. Now this doesn't need to be hugely formal. So at my workplace now it's incredibly formal. Everything is code reviewed before a pull request is merged into master. But like 9 months ago that wasn't the case. 9 months ago developers were committing and they would occasionally code review and look at each other's things and put comments on it. Now that worked really well in a smaller team where everyone was continually in communication and worked out what was going on. But in a larger team we found that we had to really formalize the process. So yeah, I don't really have much more to say about code review because it's one of those things where if I was working with developers who said code review, no we don't do that, I'd say well bye. It's just, basically, it just makes my life so much easier as a tester that I just need to bring it up and talk to them and be like, developers, please review each other's code. And where are we? Right. building things for test. So those were things that you could do around code to make it easier to investigate software and make sure that it's doing the right thing to do. But there's things that you can do with your code and with your development lifecycle that makes it much easier to test. And the biggest one, absolutely the biggest one, is having a deployment system. So whatever you do with code, at some point it has to be turned into a program that can be run somewhere. And that can be as simple as a compiler step and then grab the executable and run it. But you need something that does that. And ideally you want something that does that when code is written. Ideally you want something that that when code is written, it runs automated tests on them and goes, no, we can't deploy that, and red flags it and doesn't even build it. And a deployment system doesn't have to be really fancy. A deployment system in your company can be Alice and Bob, or in your team can be Alice and Bob, you do deployment from now on. And eventually Alice and Bob, because they're developers and they're lazy, will get really bored of it and will go like, can we automate the deployment? And be like, yeah, you can. The next important thing that I find is test environments. Now, this can mean, so in my company we do mobile and we do web. So for mobile, my test environment is a specifically built version of the application that points against our test environment of the API. But even if it didn't talk to an end server, even if I was dealing with a solely contained executable, I would want something that is a test version of it as opposed to a production version of it. And the importance of that is that so we can work with test data. Now, test data isn't real data. I put things into my application all the time that no sane real person would ever try to do, unless they were trying to attack my application for security reasons, in which case I'd like to know what happens when they do that. But generation of this test data can be quite complex and quite difficult. Hilariously, one of the best solutions for that is, if you're a website or something, is to build an API that allows you to generate data into your application. So with the to-do, for example, if we had an API that let us post a to-do for it and it would show up in the page, that would be kind of useful. It could also probably derive some value for the product people. They're like, hey, we have an API, you can use it to do cool things. And then other developers could pick it up and do cool things with it. And that actually makes it easier to investigate your software and probably makes it easier to sell it if you sell it, which is useful. Two birds, one stone. And definitely with test data, you should be avoiding production data. Don't replicate production in your test environment, because something bad's gonna happen at some point to your test environment. You're deploying code that is completely broken and it'll send emails to everyone, which is handy if the emails aren't real. Or if your test environment doesn't send real emails and sends them to a product like Mailtrap. Mailtrap is an awesome paid product nowadays. You can give them money. It was great because for years you couldn't, and their system would go down and be like, what do you expect? It's free. But what it does is it gives you an email service so you can easily point whatever you use that sends email to, and then they all just show up in a page on the internet that you can log into. So you can be using, blah@example.com, and everyone can see that email. So testers can see that email, developers can see that email, which is really handy when you're trying to debug problems, having a shared test mailbox. So let's jump down here to another product while I'm doing product shout-ups. It's really useful. Raygun. Raygun's done by Mindscape, which Marcus kind of burned earlier with their other products. But Raygun is a really awesome product. Marcus likes Raygun. And if he doesn't like Raygun, he really likes Raygun because he sends joke Rayguns to it all the time. He really does. You really do. But it's an error tracking tool where the error tracking is online, so your application sends data to it whenever it crashes, and it's got your whole stack trace and everything. So if you manage to bring down your own local box, or if your web server stops responding to something, or if it's a mobile app on somebody else's phone, you've actually got a crash stack trace data, so you can work out kind of what went wrong there, which is really great. It can also notify you on demand of things when happening, and it's really, really good. You should have a look at it if you don't have anything like it already. Let's go back. Tester command, right. So tester commands are a very interesting thing. So in the application that I have at work, we have a concept of feature flags. So things get turned off or on at a feature level in production, which is useful because we're deploying websites continuously, so it allows us to deploy a new feature, go, oh, hang on, that didn't quite work, and turn it off so no one's affected. Or it allows us to progressively ramp out a feature that we know is going to affect and change people. And one of the biggest uses that we actually have for feature flags, in my opinion, is tester commands. So in our test environment, you can run things that shortcut things in production. So for instance, you have to verify a SMS code in order to sign up for Pushpay. In our test environment, you can use 1, 2, 3, 4, 5, 6. Now that's really important because that makes it faster for me to investigate problems. It's also really important that that never ever happens in production. So one of the most important pieces of code in our code base is where when it goes, if tester commands is on, tester commands is a function that goes, okay, is tester commands on? Yes. Okay. Am I in the test environment? Yes. Okay. Am I in the production environment? I'm in the production environment, error. Throw an exception, everything stops. So where was I going with that? Tester commands are really useful because you sometimes need to write things into your application that, once again, makes it easy to investigate. Yeah. Odds and ends. Right. I have ripped through this. Okay. So, one of the things that I often find when I'm talking to other testers is that they ask me how good I am at SQL. Because inevitably, wherever they work, there'll be an SQL database, and they will be asked continuously to go into the SQL database and check it to make sure that a certain state has occurred. Don't do that. Because is your product a database? Are end users going to go into the database to find out if their things happened? Of course they aren't. Are your frontline support people going to go into the database to see what's happened? Of course they're not, because you're not going to give them that level of permission because the database contains everything. So don't make your testers dive into the database in a way that you wouldn't let people dive into it in production for normal issues. Make it a pain point. In fact, make it the person who is responsible for production delving into the database to delve into the testing database. Because very quickly they'll get very sick of it and start writing tools that can access the information. And they'll start writing tools in production that can safely access debugging information without having to manually dive into things. And that makes everyone safer. And that's another one of my points. Some things are painful. Some things are meant to be painful. If you find something is getting in the way of making sure that something works, and it does it repeatedly, but it provides some sort of benefit in making that painful, then keep the pain. Some people don't see how this makes sense. Okay, what's a good example? What's a pain point that we keep? I'm looking at some of my coworkers now. Yeah. Database diving was definitely an example of that. There's some things that we keep painful in our deployment pipeline. Yeah. Yes. So one of the things that we do actually keep painful is committing code straight into master. You just can't do that. And the reason that we do that is so that nobody does it and then we accidentally deploy something and then it's like, well, what happened? There is an explicit process in order to get something into a deployable state. And some developers find this quite painful. And we keep it because it saves us pain down the track.
Verification tests, maybe an example.
Oh, yes.
So having tests that you have to verify in order to
Yeah.
make a change.
Yeah. So one of the interesting sort of code level unit tests that we have in Pushpay uses reflection across the code base so that if you do something, if you add something to an enum, for example, you add something to a particular method, you have to explicitly put it into this verification test that I have done this, which is really useful in breaking up what we used to call humongous monolithic admin data service, which actually segues quite nicely into my next point, which is software projects change over time. And whatever practices and procedures and things you have in any point of time should reflect what's happening in your software at that time, and should make it easier or possibly harder to investigate what's going on in your software at that time. About the only thing that doesn't change with your software project is the people that you're working with. No, actually, you can change the people that you're working with. But, yeah. So that was Morris rambling about how to build testable software with the assumptions that software's built in teams, software's complex, and software involves changing state. I hope you enjoyed listening to me and maybe took away something useful to think about.